Hi, in this video I would like to show a design pattern for AI agents that we call token vaulting. Giving agents long-lived, high-privilege access can create issues where the agent acts beyond its intended privileges. However, current authorization architecture usually does not allow the user to stay in full control of the agent's capabilities. Very often, users need to grant the agent excess privileges or create standing privileges where the agent retains permissions for longer than needed. The token vault design addresses this by making sure that agents are given only short-lived, least privilege access to external resources. Let's take a look at how it works in action. First, I need to set up connections with the providers I plan to use with my agent. I log in to the token vault with my account. Then I see a list of the available providers. These are enabled and configured by the Security Identity Server's administrator. When I connect to a provider, the token vault runs an OAuth flow against the provider's authorization server. I can review the permissions that I'm consenting to, and eventually the vault will receive a high privilege access token, a token that allows calling the provider's MCP servers, and a refresh token to provide long-time access. The tokens are securely stored in a vault. Here, I connected my GitHub and Atlassian accounts. Once connections to providers are established in the vault, I can set up an MCP connection from my agent. Here I'm using Cloud Code. Note that MCP URL is the one provided by the vault. I'm not connecting directly to the provider's MCP server. I need to authenticate connections to my MCP servers. I authenticate against the vault's authorization server, and as a result, Cloud Code receives a low privilege access token. This token is used to make low privilege calls to the underlying MCPs. For example, after authentication, Cloud Code will ask the MCP server for a list of available tools. It will call the vault's URL with the access token it just received. The vault's gateway performs a token exchange. It exchanges the token for the token kept in the vault, then forwards the request to the original MCP server. Low privilege operations do not require any additional user consent. Things like reading the MCP server's list of tools or simple read operations are performed seamlessly. Here, I ask the agent to read the data from Jira. The vault keeps a policy to decide whether the agent is actually making a low privilege operation and will release the vaulted token. Eventually, the user will call an operation that requires elevated privileges. I will now ask Claude to create new issues in a repository if it decides that it's necessary. Now the vault's policy stops the token exchange. The gateway returns an elicitation request asking the user to consent to a high privilege operation. Once I give the consent, Cloud Code will receive a new access token that contains the elevated permissions. I can now retry the operation with the new token. The vault will now allow for the token exchange and will release the provider's token. The tool call is successfully finished, and I can see the new issue created in my repository. Note that the agent never handles the vaulted tokens. They are only released at the vault's gateway level and inserted directly into requests forwarded to providers' MCP servers. If you want to learn more about securing APIs and AI agents, take a look at the resources at curity.io. Thanks for watching.